All right, let's take a look at these four problems. And really, we're just deciding, is this a growth? Is this a decay? And how does that affect the formula as we plug into it? And so the formula is up here in highlighted. And so let's look at this first one. Rentals in a high-rise apartment building get more expensive higher up since the views get better. It's an interesting way to charge rent. The ground floor, which is considered floor zero, is $1,780 or $1,780 a month, and the rent increases 4% per floor. What's the rent on the eighth floor? And so this is this is exponentially changing in and think about how it's changing. Is this going to grow or decay? Meaning, is the money going to increase or is the money going to decrease the higher you go? Yeah, I mean, it says pretty plainly here, it gets more expensive the higher up you go. We want to be on the eighth floor, pretty high up. And so it makes sense that this is a growth. The value or the rent cost is going to be much more expensive or more expensive, maybe a better way to say it. All right, y equals, that's the yield, that's the outcome, that's the answer you're going to get for the time and all the details that you're looking at. And so we're going to plug in here. A is the amount it starts at. It starts at 1,780 times 1. And then there's this funny looking plus or minus. Plus or minus is not some new symbol in terms of like some new concept, except it just means you're either going to add or you're going to subtract. And in this case, if it's a growth, you're going to add. So it's 1 plus. Just means we don't use subtraction for this when you're growing. And the rate is always in a decimal form. It's given to us as a percent. 4% is 4 out of 100. And so if you can divide that on your calculator if you want to see it there, but 4% is 0.04, not 0.4. Don't fall into missing it because of that tiny little detail that actually makes a really big difference. 0.4 is 40%, not 4%. So make sure you use 0.04. And then it's raised to the T power, and T stands for time. Or in this case, how many times are you increasing the floor? Think of it that way. So we're going up to the eighth floor. So we're going up 8 times from 0 to the 8th. All right. And that is what you would jump over to your calculator and type in exactly like this. If you want to simplify and say this is 1.04 because you want to just add this part, you can. It comes out to be about $2,436.05. Remember that this is money. So dollars and cents make sense. Even though your decimal is much longer than that, money is just dollars and cents. So you just want to go to the hundredths place there. All right. Let's look at the second one and decide growth or decay. A rubber bouncy ball is dropped from a height of 155 centimeters onto a hard flat floor. After each bounce, the ball returns to a height that's 19% less than the previous maximum height. So I'm imagining this ball being, bouncing, and then it comes back up and it bounces again, and it comes back up and bounces. And eventually, it's just on the floor, right? So the bounces are getting shorter and shorter over time. Well, that is a picture of a decay. And so, I mean, it says here it's becoming less each time, less than the previous height. So let's go back to our formula. Y equals the amount at the beginning. It was 155 centimeters off the ground times 1 minus, because we are not adding this time, we're subtracting because it's decaying, it's getting smaller. 19%, that is 19 out of 100. Percent means per 100, and so that's 0.19. So 1 minus 0.19 to the T power, and T is the time that it has bounced, and so 7 times. All right. Calculator is going to give you that, not 155, that's where we started. It ends up being at about 35.46 centimeters. Now, this did not tell us how to estimate or round the answer. So if you were thinking about 35 centimeters, that's fine. Yeah, somewhere in there. So makes sense. If it starts out at 155 centimeters after several bounces, it's only going to be, be a little bit off the ground, not quite as high or off the floor. All right, so we've got growth and we've got decay. Let's look at number 3. An employee receives a 3% raise once a year. Initial salary is here. What's the salary after 9 years? So, I mean, a raise indicates that it's going up, right? Their salary is increasing. You want it to look like that, right? You want your salary to jump up. I don't know if it's going to jump that much, but we at least know that this is a growth that probably looks more like this, right? Something like that. All right, y equals the initial amounts 58,400 times 1 plus, because it's a growth, 3%. So just like 4% is 0.04, 3% is 0.03 to the t power, and the time is 9 years. So 9. All right, so that comes out to be about $76,198.75. Again, it's money, so you want to make sure you're clear that you understand that it's money and that you label it with like dollars and cents there. And, each time ask yourself, did my starting amount and my ending amount make sense? If I started at 1780 back here on number 1 and it's growing, the rent's going up, an answer of 2436 makes sense. If I'd gotten an answer like $500, that would not make sense. That's not increasing as you go up to a higher floor. They started out making 58,400. It's a growth. So making $76,198 makes sense in that it has grown. It has gotten to be a bigger salary. All right, number 4, car rental prop company, blah, 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 assumes each car depreciates by 9% a year. If the initial value is 38.8, what's the value after 9 years? Okay, the word depreciates here tells us that it is decreasing in value. So the value might be here, but over time it's going to decrease. So y equals, we start at 38.8. And because this is a decay, it's depreciating. That's a decay. We're going to subtract again. 9%, just like 4% and 3%, were 0.04 and 0.03. 9% is 0.09. And 9 years old, so that's the time, 9 years. That comes out to be about $16,603.68. I'm looking over at my answers. When I'm looking, I'm making sure I tell you the right numbers, because the focus of this is not the final answer. The focus is on getting there. That is the most important part of this. Understanding growth and decay and how to plug it into the formula. And once again, we started at 155, we ended up at 35, that's a decay. We started at 38,800, we ended up at 16,000, that's a decay. Those numbers got smaller. All right, I hope that helps you. I'll see you next time.